Laws of chemical combination. So what are the laws you have that we are referring for the basic things of chemistry? For example, in our bridge courses, we usually read what do you mean by chemistry, what are the things is present in chemistry, that and all, right? So like that, we are reading now what are the basic laws which were taking place in chemistry that in the initial days of development. That is called laws of chemical combination. So first, we are reading an law of conservation, law of conservation of mass. Do anyone know this? What do you mean by law of conservation of mass? Conservation. What do you mean by that? Law of conservation of mass. This theory is launched by Antony Lovisto in the year of 1743 to 1794. It is the duration of us. So this is going to ask you for the 1 marks question in your CET and NEET examinations. Okay. Matter. It's not a matter. It's law of conservation of mass. What do you mean by conservation? I'm asking. Conservation. What do you mean by conservation? Yes. So it's by Antony Levisto. He is during the period of 1943 to 1794. It is not an working on the conservation of law. It's a time duration he lives. Okay. So this law is proposed in the year of 1789. Okay, in the year of 1789. What he said means he is carrying out an experiment regarding the combustion reaction. So this is very important. Please note it down. He carrying out an experiment regards combustion reaction. You can no regards combustion reaction. Okay, so what he'll do, he just try to propose a law in terms of combustion reaction. First, what he did, he takes some chemicals that which having the capacity of combustioning on the presence of oxygen. So usually, if you want to say combustion should occur means it should be in the presence of oxygen, right? So like that, what he did, he just take up one combustion reaction and he just start analyzing of it. So after working of several years upon those chemicals, so he came to the result that masses of reactants and products are masses of reactants and products are not be destroyed or be created. You are all exactly super. Your screen is not visible. Screen can't stay there. Screen is visible. It's clearly visible. But today I think I focused it clearly. You do one thing, you just please log out and log in. Maybe a issue that happening. You just log out and log in. For others, the screen is visible because I could have seen that in my laptop. Hmm. Rakesh, do that. Hmm? Okay, thank you guys. Okay, so what he did, he proposed the law of conservation of mass in the year of 1789 by carrying out an experiment called combustion reaction, and he got a result that a mass of a reactant and a product neither be created nor be destroyed. Okay, neither be created nor be destroyed. So next, everyone will no need to agree about this, right? So some will argue on that. So how can you say it's neither be created nor be destroyed? If the mass of a chemical is there, you can reduce the size of it, and by reducing the size, you can destroy the mass of it, and by adding a chemical for it, by adding an atom of it, you can gain the weight for that. So how can you say it's neither be created nor be destroyed? Then again they'll start trying it more. Then next comes to the picture that hero is called as Joseph Prost. Joseph, Joseph Prost. So he stated a law of definite proportions. So when other scientists in the team well started trying it out, the Antony's theory of law of conservation of mass, then next one came to the picture is called Joseph Prost. The duration of Joseph is 1747 to 1826, and he proposed a one more law that is called defined proportions. Law of defined proportions. He's an French. He's an French chemist. He's an French chemist. He started that giving a compound that containing exact what he told the previous one. What the Antony is what he said. He having a mass is fixed. He told like that, right? Next, Joseph, what he told in his own terms that is called a compound. A compound always, a compound always contains exactly the same, exactly the same proportion of elements, elements by its weight. What does it mean? It means to say, I'll just decode the laws, what this statement is. Okay. So you should know one thing. Uh, if you want to explain anything, including definition, you can write in your own words. For example, what do you mean by chemistry? If you'll ask, you can manipulate the words here and there, and you can, but it should be of meaningful. Then you can write, and you will get the marks. Like suppose it's a branch of science which deals with the study of chemicals and combinations and all compositions, that's fine. So if you just re-alter the words also, no problem. But in case of laws, okay, remember this, if you writing in case of laws, yes, you should read this name, Tasneem. You should read this name. Okay, in case of laws, you should know that word should not be altered. I'm not saying the sentence, the words also should not be altered. You should read as such, you should write as such, then only you'll get the marks for laws, because It's a law proposed by a scientist. So we can't change according to our things. So, okay, you should write like that only with a double quoted mark. Okay. Compound should always contains exactly the same proportions of element by its weight. It means to say whatever the compounds you have used in the chemicals, that should be have the, if you are saying it's have the same proportion. It means to say if 1 gram, 1 gram, or we can say like 1 into 1 centimeter, any object if you are taking, that weight of the object will remain always same in that compound. He's saying like that. I can give an example for the betterment explanation of this words. So suppose you know that H2SO4 is a sulfuric acid. Is it right? So what he said means, so here H2, hydrogen, we have 2 in number. Okay, hydrogen we have 2 in number. And oxygen we have 4 in number, and oxygen one molecule carries the mass 16, 16 fours are 64. Okay, 64. So in sulfuric acid, this oxygen mass is always 64. It will remain constant for all the proportions of the LCRA. It means to say wherever you are taking the sulfuric acid, either it may be in your lab or it may be in other chemical shops or whatever, wherever you're taking, that always the mass of an compound, it always remains same. Okay, he's saying like that, and that's true. You can just analyze if the composition or mass has been keep on changing based on the external features or temperature. We can't say that's a fixed. Is it right? So for that I can give you one more example. Where you are taking it, the composition and the mass of the substances is always remain same. Okay, that is the law of defined proportions. Is it clear? Is it clear? Shall I move? So it's giving some example has like a naturally synthesized or naturally presenting sample versus artificially synthesized samples. Okay. You have one small chart like thing. This is a percentage of copper. He's taking oxygen and carbon. Okay. He's just comparing the naturally existing atoms with your synthesized atoms. What may be the percentage of it? So he got a naturally occurring copper is 51.35, and for the synthetic also it will be the same thing. And for oxygen is 9.74. It's not a mass, it's not a number, it's just is giving a percentage of. Okay, for carbon it's 38.91 for both. So then by giving this data, he's concluding that always the proportion of a compound or a mass of a compound is remains same. Okay, clear? Please write on the chart. Next, law of, it's a third law of multiple proportions. Okay, law of multiple proportions. Can you say one more time? Okay. Let's see. Carbon 9.74. So what he told means the mass of an atom or an element will remain same in a compound. So in your sulfuric acid, the oxygen mass, it seems to be 64, then always the oxygen mass in sulfuric acid should be 64. He's not saying the oxygen mass in wherever you are going that is 64. He's not saying like that. He's saying in sulfuric acid, the mass of oxygen should always 64. That's right. That's right. Suppose if the water molecular formula is H2O in Bangalore, if it is changed in Uttar Karnataka has HO2, it's not in constant. It doesn't do like that. It's not like that. Because of that only he's saying it's having a same proportion. It doesn't make any changes in the mass of the elements. About chart, so you might have confused with how we can synthesize the carbon, oxygen and copper, right? So naturally occurring means that is occurring in the free state, as such he is collecting and he is reporting the percentage. And one more thing, with the composition of other thing, he is isolating it. Sorry, is isolating it and he doing it. That is called artificially synthesized. Okay, that is artificially synthesized. So naturally occurring means has such copper is available, oxygen is available and your carbon is available in the free state. So he's collecting it up and calculate the percent of it. And for synthetic one, he's removing the composition of oxygen and carbon and he's taking out it. Then he's asking for a percentage. So when he's comparing the naturally occurring free state percent with your synthesized percent, both are showing the same values. Both are showing the same values. That is the thing. He says that the compound always contain exactly the same property. He's not saying it may be. He's saying exactly the same. He's noticing that. He's doing the experiments and by that he's getting the answer that it's exactly the same proportion of elements by its weight. Okay, is it clear, Ullas? Okay then. Next, law of multiple proportions. Do you know what do you mean by proportion? This is the law of multiple proportions. Law of multiple proportions is proposed by Dalton in the year of 1776. Sorry, in the year of 1803, and the duration of Dalton is 1776 to 1884. So he proposed a theory called if two elements can combine to form more than one compound. Okay, if two elements are combined to form more than one compound, the mass of one element that combines with the fixed mass of other elements or the ratio of small whole number and he's giving the example also. What he gave means, see, suppose he's taking the example of water. I'll just explain this and then I'll take up the example, then you can understand better. So just try to read it in a slow way. If any two elements can combine to form more than one compound, it means to say whatever the compounds elements you have, that if any two elements, for example hydrogen and oxygen, are combined to form and more than one compound. It may be formation of one compound or it may be formation of one to two compounds. Okay, any two atoms will combine to form any elements will combine to form a compound. Okay, that mass of one element, he's not saying mass of two. Among those two, among those two elements, one element that combine, one element that combine with the other, right? So one is combining with and one more. So the one element having a fixed mass, that is fixed. We can't, one element mass should be fixed. of the other. So he's saying that among those two, one element mass is fixed. And what may be that fixation? The fixing rate is to be small whole number ratio. So he's saying that in a simple words, if I need to explain in one word, what I need to explain means the compounds are formed by the gathering of elements. Among those two elements, one elements having small whole number value. Okay. So for your better understanding, I can explain. So now by giving that example, I'm explaining. So we are taking the example of water. Okay, water. So water, hydrogen 2 in number, so you can say it is 2 grams. Oxygen 8 in number, so the mass is 16, so it's of 16 grams. Okay, so then water mass total it will become 18. So by seeing this, try to understand. Any two elements are combined to form a compound. Okay, combined to form a compound. More than two compound. This also we can get. Hydrogen and oxygen combines to form water also, and this is hydrogen peroxide. Okay, hydrogen peroxide also we can form. So what he said, okay, what he said means the hydrogen and oxygen combination, we can get two things, that one is your water molecule and second one is your hydrogen peroxide. So what we are getting from those two, among them, one of the mass should be, okay, among them, one of the mass should be smaller. You can see here also the hydrogen having a same, but oxygen 16 twos are 32 grams. So the oxygen only changing, but the hydrogen remains same. That is same molecule or the same element having a smallest whole number value. Okay, are you cleared? By seeing the example, I think you are able to understand. Mass of this is 34 grams. So why we are taking mass means that is called Avogadro number, that I'll explain it later. So are you getting my point? This is a Dalton law. This is very important. Dalton law. Are you getting my point? Can you able to understand the law of multiple proportion? Tell me fast. Okay, fine. I'll explain in 2 seconds again. Just a review of it. Two elements are combined to form more than one compound. The mass of its combined with the fixed other elements are of smallest whole number ratio. Okay, so hydrogen and oxygen can combine to form a two compound. Among those two, one is fixed. That fixed element having an ratio of small whole number. It remains same always to hydrogen, right? So that is the thing here.